industry changing. The automotive industry of the next decade is not going to be only about vehicle manufacturing or vehicle sales. It is all going to be part of the energy industry, part of the energy ecosystem, right? And automobile would be a vehicle to deliver energy. It is an energy delivery mechanism. So let's see what all it entails. The new energy ecosystem evolves around energy mobility. These are all emerging opportunities in the industrial landscape. The context is India as well as global. In energy, we have renewable energy options. We all know solar, wind, and battery ESS is also energy emerging in a big way. Energy delivery ecosystem. This is where energy deliver. Energy has basically three sort of compartments: energy generation, energy evacuation, transmission, and the end use. So this is where the energy delivery ecosystem will develop. Then comes mobility, our industry, automotive industry, which is where electric vehicles ecosystem is developing very fast. Today, as we all know, the alternate fuel, in the alternate fuel, if we talk about alternate fossil fuels, then battery is the only mature technology. Hydrogen will come as we see hydrogen developments are going on probably at TRL 5 or 6. So next maybe 5 to 10 years, hydrogen will become another option for the OEMs. Then drones and UAVs, another very, very interesting space to be in currently. And I will explain a little bit about this because we have just invested in a drone startup. Mobility as service, we all know that the asset acquisition is reducing. The new, as far as personal cars are concerned, the millennial, the new generation doesn't want to own cars. And shared mobility as a service, these are all opportunities emerging as revenue services. Very interestingly, Maruti, we know today makes close to about 150,000 odd cars for the taxi segment. They have a brand Tour as Tour M and all that. So it's a very, very smart move on part of mobility market leader like Maruti to get into mobility space. Connectivity. This is the new digital universe of data acquisition, processing, connectivity and feedback. What it means is that any vehicle today, and particularly EVs by design are connected vehicle. Battery has to talk to the motor controller, etc. And then the extension of it is you acquire that data, then process it, or you have a cloud connectivity, then feedback. So what it means is that the vehicle is becoming a huge data center on wheels. How to do it, what is the strategy, what is the hardware, software, etc. required, those are the opportunities. Data as revenue source. Now this is very interesting. These are the new emerging opportunities for the OEMs. A car on the wheels is collecting enormous amount of data, personal data, what you are doing, where you are going, your purchases, your selection of the services. So it is like cell phone. Okay, phone today has got connectivity, it has got commerce, it has got content. So all three, and it also makes phone calls. You can make phone calls, but other than that, you do a whole lot of things using a cell phone, whether it is commerce or banking or music or infotainment, etc. This is what has come into automotive industry. Just to let you know, a company, of course, Tesla is, we all know, at top of the line. Almost 20% of their revenue comes from these services. So this is very interesting for the OEMs to incorporate. So what I'm trying to say here is that energy, mobility and connectivity, all three are merging in the auto industry. So whatever you do, wherever you play, please keep this in mind that auto industry is not going to operate standalone in a way that we just make cars and forget about it. We just make vehicles and we forget about it. Same way it applies to the components industry. If you are manufacturing, for example, powertrain, motor, controller, so you are part of the entire energy EMC ecosystem. You are delivering energy, you are also capturing data, and the data is going somewhere. Okay, so what happens to that data? We will talk about it, and there are other issues involved with it. Let's talk about the renewable energy. I think we all know India has gone big on solar. In last 10 years, the solar alone attracted about $20 billion of investment, and India next year, this current year is planning to issue 40 gigawatt tenders for solar and hybrid projects. So we all know, almost 500 gigawatt of renewable energy is going to be installed in the country by 2030. So this is not too far, 2030, just about 6 years, and a huge amount of investments are coming into this. So battery energy storage system, it is another aspect very closely linked to the automobile batteries. I'm talking about the EV space. EV batteries, after the usage in the automotive, have what we call the second life. This is where the batteries will be deployed, as energy banks, and already a lot of public sectors like NTPC, BHEL, etc. are taking out large tenders, to set up these ESS, energy storage system. India is planning to have 60 gigawatt of battery storage capacity by 2030. In the US, already it is there are several cities and counties who are running only on ESS. They have de-linked themselves from the main grid. So this is a very fast emerging alternate source of energy. India plans to scale it up to 140 to 200 gigawatt of 2040. Just to put this in perspective, our total installed capacity today is somewhere around 500 gigawatt. Okay, so what we are talking about, close to about 40% of today's installed capacity. Of course, the installed capacity itself will be much higher, because India will need humongous amount of energy as we grow to 5 trillion and maybe more of our economy. So this is a completely what we call a smart grid, not going into the technicality of it. The battery, of course, is stationary. The energy gets fed into the grid. The grid decides, when it needs to evacuate the energy from the battery system, and that is where the smart energy comes into play. So this is where the link with the automotive industry comes in, because again the BMS will be used, the used batteries or second life of batteries would be consumed. Also the V2G, vehicle to grid, will happen. Now let's talk a little bit about hydrogen. Why I'm saying this? These are all new fuels which we are seeing in our lifetime. Hydrogen is a very interesting fuel, according to me. Humans are changing fuel for the first time. This is an interesting perspective. First we had wood, then we went to charcoal, then fossil fuel to hydrogen. So this is the fourth time humans are changing the energy source. So around 22 billion is going to be the hydrogen market in India, growing at a CAGR of 11% between 2023 to 2030. 22 billion US dollars, hydrogen. Hydrogen will be applied across various sectors, apart from automotive industry, as we know. And several industries like steel, cement, etc. are going to, fertilizers are going to use hydrogen. And also several others who use other source of fuel for their captive use today. So already we know green hydrogen policy of government is there, and a lot of money is being pumped in. Government allocated $2 billion for green hydrogen policy to generate 5 million metric tons by 2030. This is very important. 70% of it is going to be exported. 70% of this hydrogen, and hydrogen may be exported in either gas or liquid or ammonia, which is a hydrogen carrier. So all those technologies are going to emerge. So what I'm trying to say here is that hydrogen will be applicable not only for automotive usage, but for other usage as well. Okay, this is V2G. As I said, you can see the schematic here shows we have the smart charging station, then we have the vehicle, and we have the smart grid at the back end. What I was saying earlier is that the entire grid will be a smart grid. It will decide what time, suppose in the peak time, instead of the main source of power, when the grid comes under pressure, it may ask the to take the energy from the battery banks, from the ESS, or in future when you have sizable population of vehicles, so vehicle to grid will kick in. So all these are going to happen very soon in next few years. Already in other parts of the world these are happening. Vehicles are being designed for bi-directional charging, wherein the vehicles idle for a large part of the day when you come to office, etc. So the vehicle can be used as a energy source. So this is the new shift that we are seeing in the whole energy ecosystem. Now let's talk about the mobility. We talked about energy. I'll talk about mobility now. And in mobility, when we talk about alternate or the emerging mobility, the discussion is about the EV, electric vehicle. This is the most significant and profound change we are seeing in our lifetime in the automotive sector. I think without a shadow of doubt, this is the most significant development we will see in the mobility landscape. For last 150 years, the automobile has been in existence. Now let's see how EVs are different from the IC vehicles. EVs, we know, the energy source is different, etc., etc. But what it means to be a manufacturer of EV or part of the EV ecosystem. IC engines were basically built like transportation device, right? Going from point A to point B. We make the vehicles, we have to manage the emission, the tailpipe emissions, the norms are getting stringent day by day, etc. So that was a very big focus. Economics, of course, cars had to be cheaper, the price sensitivity of the market, various segmentation, etc., etc. So these 3 or 4 used to be the biggest challenge for any OEM. And all the time discussion in the boardrooms or discussion with the staff, I think Murli will agree with me, was in Maruti and vendor base in other OEMs was also about these factors, how to make the car cheaper, how to reduce the price, how to increase the market share, etc. Now in EV, there are some other dimensions which are getting added. EV is part of the energy ecosystem. For the first time, OEMs are being made responsible for the fuel. This is a very significant change. Imagine Maruti being asked to sell petrol as well, What Indian Oil does or BPCL or HPCL does today. Imagine if Maruti or Tata is asked to do that. Would they be able to do? Would they be able to handle the enormous amount of the supply chain complexities that go into fuel delivery? So this is what we are talking about here. At a very large volume, and last couple of weeks we have had several announcements from Maruti. They have publicly they have declared that next decade they're going to have a very large share of non-petrol vehicles. In fact, C.V. Raman, the CTO, has announced that the petrol share is going to be just 18%. 18%, okay? And 18% of 4 million cars. Maruti is going to double the car capacity. I hope you all know they are going to set up new plants in Gujarat and Haryana. So just 20% is going to be petrol cars, and other 80% are going to be non-petrol cars, which will include battery, which will include hybrid and CNG. So this is an enormous shift the Indian industry will go through. We will see. The questions are, of course, what happens to the auto component industry, the people who make, parts for the IC engine, petrol engine, etc. Software-defined vehicle. Vehicles are becoming more and more software-defined. The software is the basic software, application software. The content of software in a modern car is more than 50% by value in a modern car. This is huge. 50% of the cost of the car is software today. Okay, and this is going to increase even more and more. So this is where the opportunity lies. So I think the whole mindset of new generation car makers, vehicle makers will shift from hardware to software. You have to think like a software company, you have to think like an IT company, you have to think like a IT services company. What kind of software you want to pack it into your vehicle, what kind of application software you want to put it into your vehicle, and what are the monetization avenues with that software. Okay, software updates, etc. Mobility as a service we talked about. So economic value creation through new avenues, carbon trading, etc. So these are the new revenue generation opportunities emerging in the auto industry, which were not there earlier. Through carbon trading, carbon trading is coming to India very soon. The credits would be available. You can either trade it or sell it to the industries who need it. That is a very big opportunity emerging for auto industry as well as other industries. Let's talk about what are the numbers. I just gave you an example of Maruti Suzuki. So today two-wheelers is 5%, three-wheeler is a success story with 55% of electric vehicles. Trucks are almost zero, and we have 2% cars and 5% buses. Now look at this 2030. 2030, we will have 30% two-wheelers, 70% three-wheelers, 10% trucks, 10% cars, and 50% buses. So major conversion will happen here. 30% of two-wheeler, you know what it means. We make almost 20 million two-wheelers, 2 crore two-wheelers in a year. So 1/3 of that is going to convert to electric. So that's a massive opportunity size for auto industry, auto components industry, and as I said, the tech industry. So based on the market analysis and projection of various agencies like Niti Aayog, etc., we estimate the EV volumes. I personally think that 2026, which is just about 3 years from now, the inflection point will happen in EV and the penetration will cross around 15%, and this is where the explosive growth will happen. So if you see the numbers here, I just plotted. So these are all big numbers. So what it means, if we have these conversions, we are going to have an EV powertrain market of almost $14 billion US, 14 billion. Based on current prices. And battery BMS, the entire energy system is going to be somewhere around 20 billion. Now battery economy itself will develop in sync with this, because battery economy has several other elements to it. Right from battery generation, there is battery charging, then second life, then end of the life treatment, which is recycling, etc. So the whole battery economy is going to be another economic universe along with the electric vehicles. The market for batteries powertrain alone is going to be around $35 billion US by 2030. 35 billion. The entire auto components industry today, just to put this in perspective, is close to $50 billion. Entire auto components today in India. So we do see only these two, the battery and the EV powertrain. When we talk about powertrain, we are talking about motors, controllers, and the other, the drive lines, etc. So these two are going to be very, very substantial opportunities. Battery economy revolves around the life cycle management of batteries. As I said, battery manufacturing, then battery charging, which is a constant, continuous revenue source, or battery swapping, whatever will generate economic value. Various technologies are in the evolution phase. We know that other than lithium ion, there are other technologies developing. India will need to set up around 100 gigawatt by 2040 to meet the battery requirements in mobility and ESS. 100 is actually on a very conservative side, I think, because there will be a replacement demand of batteries as well. So probably we will, and also ESS. So probably we'll need about 200 gigawatt. Today we are at zero, almost zero. So you see, going from 0 to 200 in less than 20 years is a massive challenge as well as opportunity. And to put this in the perspective, the entire global capacity today is close to about 1000 gigawatt. So 1/5 of this is going to be required in India. So key challenges here are technology, supply chain and economics, battery production, battery charging, second life, recycling, and everything is going to be data driven. The government is coming up with something called EPR regulation, which means the end of extended producer's responsibility. Means if I am the producer of battery or producer of car, then I am responsible for end of life treatment, which is recycling and feeding back the materials into the supply chain. So there are certain targets already being discussed. How will you do it? If you are a maker of vehicle or a maker of battery, how will you recall that battery? How will you retrieve it? What is the system, etc. All those challenges will have to be sorted out along with the entire recycling mechanism. Indian auto market is changing fast. Let's not underestimate the speed of change. I'll just give you a small example. In 2013 to 15, the market consisted of 51% diesel car. Almost half of Indian car market was diesel. Today, diesel percentage is reduced to 17%. So from 51% to just 17%, it is constantly reducing. People don't buy diesel car except for the high-end SUVs. That is the only segment which consists of passenger vehicles, diesel vehicles today, right? So the question is, when the industry reduced from 51 to 17%, what happened to the component manufacturers? Did they adopt, or they, sort of could not survive? Only high power SUVs has diesel. Maruti has no diesel. Only Mahindra, Tata Motor we know, and I think Toyota. Similarly, in 2015 to 2017, the entry-level hatchback cars like Alto, Wagoner had almost 51% market share. Today it is less than 30%. The entry level is reducing, and the mid-size cars segment is increasing. So again, the same story. The people who used to supply parts to these platforms, they lost a lot of business opportunities. So considering this, the speed of change for next 10 years is going to be faster than most of us sitting here think. I think personally, the EVs and other non-fossil fuel, whether it is ethanol, methanol, makes CNG, maybe hydrogen, will happen faster than most of us imagine. I definitely do see the EV volumes coming to 30%, as I showed you some of the numbers. 30%, 1/3 of the industry would be electric. In 2 and 3 wheelers, it could be even more. Now, let's talk about the connectivity. I covered the energy, I talked about the mobility. Now, a little bit about energy. Data analytics in the batteries for EV, battery in the cloud. This is an example I have taken from Bosch's presentation. Battery in the cloud, the product they call it is battery in the cloud. See, the battery is put in the vehicle, and through the sensors and other data acquisition modes, they capture the data related to each individual cell. Now there could be thousands of cells in a car, for example. So at the cell level, they are able to capture that data. Now that data gets transferred to cloud, their own cloud. It gets processed there, and through technologies like machine learning, artificial intelligence, etc., they can decide, or the system can decide whether the battery or the particular cell is likely to fail. So it will red flag that, hey, your battery is likely to fail, so please stop. Or if there is any other issue, there is a thermal management issue, fire issue, safety issue, charge SOC issue, etc. So this is the up to the extent they are gone and designed their connectivity platform. And this is Bosch. Aging prediction, etc. So predictivity analysis for batteries they can do. Same way, for motors, controllers and other critical items, the using artificial intelligence, the predictions can be made for vehicles. Now, how will Bosch sell this whole product? I don't know. We'll have to see whether they will sell it as a service or they will bundle it with their batteries or BMS. So we'll have to see. So this is where, again, as I said, there are several new opportunities emerging for the auto industry. Autonomous vehicles, again, a part of the connected mobility. Today, just 1% of the vehicles sold are equipped with partial autonomous driving, level 1, level 2. Level 5 is the highest, where the driver is not required. In 2025, 60% of the top 20 OEMs plan to have a level 4 autonomous vehicle in their offering, though the application may be constrained to certain geographical areas or use cases. This is from a report by McKinsey. They expect that top 20 global OEMs, they will have autonomous driving in their vehicles. Recently, for example, the increase of vehicles miles traveled between disengagements has risen from 5,000 to 12,000 miles for 2 leading autonomous vehicle players. So this is the really top of the line technology where a lot of hardware, software, IT, etc. gets packed in, and then you decide. And particularly for India, how we all drive, and in the real life situations with so many complexities, so many unknown variables, it is extremely complicated to have autonomous driving. So connected, electric, shared, these are the the areas where we will have enormous opportunities coming in our industry. This is just an example of autonomous driving. This is a company where I am involved with. He's a scientist, computer scientist from IIT Roorkee. Last 10 years he has been developing this, and he has successfully developed level 5 autonomous driving, first time in the world. This is an Indian gentleman, his name is Sanjeev Kumar, and outstanding technology. And now we are talking to BMW for some possible alliance. So what I'm trying to show is this is not theoretical. Things are actually happening on the ground. There are serious people who are working on it, and it is really heartening to see Indian scientist, Indian engineer doing it. So we must applaud. Drones, again, this is an example I have picked up. This is a company where we have invested. So this is a military drone. Again, drones are going to be another huge, enormous opportunity. Very kind of sync with mobility and automotive in terms of the motors and batteries and the software systems, autonomous, etc. So this is an industry where there will be civilian use as well as military use. Indian military is going in a very, very big way for drones, and the let's talk about why drones. The war economics are changing very, very rapidly. The recent war in Ukraine has shown that if you have to damage a tank, you either use a missile which costs about $50 million, Predator missile that US sold to India was 89 million per piece. Okay, they charge 89 million US dollars. Okay, so to blast a tank which costs about 20 million, you have to use a missile of that value. Or in Ukraine war, they have used a drone which costs 438 US dollars, made in Turkey. Okay, so the return on your investment of a $438 which can blast a tank you can imagine is multiple times than using a missile costing 10 or 20 million US dollars. So this is how war economics are changing. And last week I was with the ex-chief of military, our Indian Army General Narwane, and we had a very interesting discussion. And he said that, you know, he's writing about one of his book is coming out very soon, 4 Stars of Destiny. And he is talking about the war of the future. See, wars will never stop, you know, as long as humans are there, you know, we like, and the superpowers like it even more. So the way wars will happen in the future, what are the strategies which will deploy, and what kind of equipment will be used. You know, the technologies will will change very, very rapidly. Even gunpowder was a technology change, right? From sword we went to gunpowder. From gunpowder then aircraft came in, bombs came in, nuclear came in, you know, and now drones. So what he said that, you know, the enormous amount of drones that Indian military is going for is huge for logistics, for you know, military use. This is a drone which is called kamikaze drone, self-destruction. It has a warhead and it attacks and destroys itself. It can also hover around, wait for the opportunity, and you know, it can blast. So these are the technologies which we will see in future. Hopefully we don't see, but these will be available to military in the world. Some of the new, okay, now I will come to some of the live cases or opportunities available where I am personally involved. These are some Korean companies with which I have you know, signed the mandate to bring them to India, find them a partner. This is a company which has a supercapacitor technology. Supercapacitor technology means it is the capacitor along with the smaller size of the battery. The supercapacitors have a challenge of bigger in size, you know, the charge density is less, but they overcame it by their proprietary technology, and now it is used, as you can see, in solar panels, drones, three-wheelers, then the forklifts, scooters, and also military applications. So this is a proprietary technology wherein the supercapacitor battery, which is half the size of a traditional battery, can be built. So this company, and the BMS is again a IP protected technology. So BMS and supercapacitor battery can be used in India. This is a very interesting technology. This is called lithium-free solid battery, essentially solid-state battery where lithium is not used. Okay, and they use their own proprietary materials. Now, yesterday only they sent me some information where the battery has been approved by NASA for their usage in their satellite system. So it's a very, very high end of or cutting edge technology, wherein we have the applications, as you can see, solar lights, motorbikes, cars, consumer electronics. Again, the technology is available, battery and BMS. So there are a couple more which I think that, yeah, this is a company where Swedish company, again they want to come to India. We are starting, and they have a proprietary powertrain technology, motors, controllers,